All right, so with part C, I think the easiest way to do this or to see where to go with this is really to remember that um, the derivative of secant x is secant x tan x. And I know in class that we were told that we don't have to remember this, but I just feel like seeing the substitution that we need to be doing in this problem is going to be so much harder if we don't remember this derivative. So in my opinion, I think you should still keep this derivative handy. In the case of a problem like this, we're not going to realize what substitution to make unless we remember this derivative. Okay, so because I did remember that derivative, and I see that I have the secant x tan x up there, that's why I go ahead and make this substitution, u equals secant x. Okay, so then first step, that's the substitution. Second step, du. Third step, solve for dx. And then going back to our original integral and plugging things back in, the denominator becomes u minus 1, which is good. We know how to integrate rational functions. And then the dx becomes 1 over secant x tan x du, this part. And so these things cancel away and we're left with du over 1 u minus 1. And this is a rational function that we might have come across several times. We might have, or at least something of this form we might have come across several times. You can integrate this either doing another substitution where you call v as u minus 1, dv is du, and you can do another substitution that way. Or you might have just had enough practice with something of this structure to know that, you know, you're just going to get the natural log of the absolute value of that denominator. So whether you want to do it in a couple steps with a substitution, or if you have enough practice with it to just go straight away to here, that's totally up to you. But either way, make sure that you're seeing the same answer. And remember, we have to go back to x's, and so the final answer is natural log of secant x minus 1 in absolute value. Remember your constants with all these indefinite integrals, by the way. And that's that.